Hey everybody, this is Mike with Plus 8 Precision, and this project is going to be taking my static three-phase converter and turning it into a rotary three-phase converter. Let's get started. Alright, I guess the best place to get started would be to kind of talk about the parts that are here on the table. Let's start off with the static converter. This static converter here, just got to make sure I'm in the frame, came with my mill that I bought a couple years ago. Temco. These things run, I think, about 50 bucks. Again, this was already on the mill when I bought the mill. The 5 represents 5 horsepower, even though the mill is only a horse and a half. These are pretty straightforward. I didn't know anything about them when I bought the mill. The guy had it wired up, turned it on, everything worked. Also, with this came a three-phase, 3 horsepower motor that was pretty much brand new. And he said his buddy hooked it all up. He wasn't sure how the wiring went, but they put the 3 horsepower motor on there along with the 1.5 horsepower motor to make up the 5 horsepower. But it's a little mystery box. So I'll pull you in close and we'll take a look at this, of what's inside of it real quick. Alright, so inside of this box what you have is you got some capacitors. These are obviously start capacitors. They're discharged. No worry about it. This comes with, like, if you want to call it a spare, but they call it a high voltage use, which is, it's not hooked up. This is the way it was. You got this one here that is hooked up. That does have a resistor on it to drain the capacitor. You have a terminal block down here, and that is labeled. Let me just kind of do this. The terminal block, as you can see, is labeled. This is a potential relay which kicks that out once the motor gets going. There's another small wiring schematic right here. But I mean, that's it right there. That's what you get for 50 bucks. And most of the time these are on back order, because that's basically all this is. And what I'm going to do in this project is try to take all of this that's already done. The engineering is already finished. This is finished. And then I'm going to extend upon this. Most of this project I will be referencing the videos put out for phase converter build from SBIRDRANCH. You know, for me, his video, his 3-part video series on doing a rotary phase converter was probably the best, most methodical, laid out, intuitive explanation of a 3-phase rotary converter that I've seen on YouTube. And I'm not trying to top him. I just want to extend on what I have here and try to lay out so my phases are balanced, because believe me, with these the static converter, they are absolutely not balanced. You have the same, you know, 236, 202, 208, 217 situation going on here, just like SBIRDRANCH shows in his video. So I've made myself a schematic. I'm no electrician. You can tackle this at your own risk. I've always been someone that's tried to do things in a safe manner and minimize any of the dangers, and that's what I'll do here. But everything is completely up to you, what you feel comfortable with, what you feel safe doing. And again, I haven't seen any videos on YouTube where they've taken something existing and expanded to it. I don't even know if this is going to work. But you will follow me through the entire process. Start to finish, good or bad. We're going to see what happens. If something blows up, you're going to see it blow up. And then I'll try something else. I'll order some more parts. But let's continue. We'll continue looking at some of the other items that I purchased to get this project on the way. Again, using SBIRDRANCH's videos for reference and the PDF sheet that he followed, the Finch converter, obviously being a little bit lazy and not wanting to spend a lot of money on a bunch of different capacitors when I didn't need them. Like I said, the motor was practically brand new, so I'm going to assume that both of my balance legs are going to be the same. And that's the way I'm going to start off. And if the voltages are different, then I will go through and order some other capacitors, run capacitors to balance them out further. Maybe smaller, maybe larger, maybe more than one. But as of right now, what I've ordered is I've ordered 2 of these 80 UF capacitors. And again, I'm no electrician. You can see the voltage range. These came off of Amazon. This is what I'm going to start off with. These 2 big ones are both the same. These actually have the 3rd terminal, which is for accessories, you know, for their intended purpose. Obviously, they're not intended for a 3-phase rotary converter, but that's what they're going to do now. That's what they're going to live life as. But here they are. I guess I could post the link for these in the description. There's 2 of these again, one for L1 and L2, which will balance out T1 and T3 legs. Those are both the same. This little guy will be the one that balances these 2 out for amperage. And based on my motor, which is 3 horsepower, again doing the theoretical mathematical calculations that I did, this is what it should run, right around here, 7.5 to 8. Again, we'll see what happens. We'll see how the amps balance out. Those are the items that you can't buy from the local hardware store or your big box store. Some things I did buy. A couple of terminal blocks. Nothing special here, just terminal blocks. And because I'm in a garage, I'm not in a huge factory, I'm not in a giant pole barn, I just have an on-off switch. It's a heavy duty 30 amp switch. Should be adequate, should do the job. If down the road I feel that it's not going to work or I feel unsafe, I will add other safety measures, an e-stop button, but right now this is what I'm going to get me going. I'm not going to order a bunch of parts that I'm just going to have sitting around collecting dust. Once everything is up and running and I'm satisfied with it, with the project, then I'll go a little bit further. Alright, what I'm going to do with these terminal blocks, because I don't need that many, I'm going to cut them in half. Nothing fancy, just cutting them in half. A little scribe line on here. There we go. Just a reference line. Alright, there they are, all cleaned up. I don't want to show you everything because everybody knows how to use a file, I think. If you want more detail, let me know. I'll give you enough detail I think is appropriate for the project. Let's keep going. Actually, what I think I'm going to do before I try to cram it into a box, just like SBIRDRANCH did, he worked on a board. His board was bigger. I'm going to do the same thing, just to prove out the concept of this, since it hasn't been done, and I don't know what this is going to do, and I don't know what the start capacitor is going to do. So I'm just going to kind of leave this alone. I'll run my wiring out, hook it up to the motor, which I have that wiring over here, and prove out the actual project of it, the theory of it, and then I'll try to package it into something nice and neat, so nothing will get in the way and nobody can touch any of the components and get shocked. So let me get. All right, and just like SBIRDRANCH did, I think I already said it. I'm going to mock this up on a board, run the wires to their appropriate locations, add the capacitors. I don't need as many as he had. Again, this is only a 3 horsepower, 3-phase motor. I did some math. We'll see how that came out. Maybe I'm right, maybe I'm wrong. Anyhow, let's go ahead and start hooking some stuff up. So I guess what I'm going to do is, this is going to be my power coming in, my T1 and T2. Those are going to be hooked up first. I did give you a close-up of that block, the terminal block, so you should understand that. Now this is the T1 as marked. And there's little jumper wires back here, so this goes from T1 to T1, T2 to T2 all the way at the end, and then this center one becomes the ghost phase. So try to lay this out so everything is visible. Okay, this will be the T2. L2 are coming out of this terminal block. It wants to call it a T3 because it's already assuming it's got a little bit of three-phase going on, a little three-phase action. Okay, and then I will hook up center one, and this more than likely will be the ghost phase. I have tested this prior to contemplating this project, and this was the low voltage leg in this circuit. So okay. Now, next thing we need to do, I suppose, would be hook up our motor lines, and I'm going to do that with some wire nuts to connect them to the block. The little wires, and if you're saying that, hey, he's not grounding anything, That's because you're right. I'm not grounded. Not at this point. I will, but as of right now, I am not. If that makes you uncomfortable and you want to try something like this, by all means, ground it. I just don't feel the need for it at the moment. So as of right now, I have this hooked up to the static phase converter, this hooked up to the three-phase motor. We can do some voltage readings, and then we will add some capacitors. So for right now, this is going to be our L1 T1. This is our L2 T3. So these are direct voltages coming out from the line going in. And then this line here to the center block is our ghost phase. Motor is hooked up. So let me turn on the power and we'll take some readings. I'm gonna leave the camera running while I go turn the power on. It's just a short walk over to the adjacent wall. Let me turn this fan off so you can hear it start. Okay, if you heard it several times, I wanted to do a slow start. This static phase converter does that. Hopefully when we put the first capacitor on, that'll go away. But it's done that since I've had this 2+ years. So let's take some voltage readings and see what we got. Okay, across the L1, L2, $233, $234, and then $200, and $210, $211. So that should be able to tell us what legs are which according to the document. And let me, if you have the document handy, you can follow through. What I'm going to do is I'm going to put some tape down here and mark corresponding to the document the VAB, the VBC, the VAC, so that way you can see which ones I'm checking and which ones where the voltage is coming from, because that was a little bit confusing for me to start with. So let me do that. Hang on. So according to the document, L1 is A, L2, in this case T2, is B, and the ghost phase is C. So when you're measuring these things, this becomes a VAB measurement, This is a VAC measurement, and this is a VBC measurement. Okay, and the document references those for how you add your capacitors. If you don't understand that, I think the document is pretty clear on that. I don't know if I can explain it any better. I mean, that's kind of what makes sense to me. And, well, let's just keep going and we'll see what happens, all right? So again, we got the measurements. So my turn the power back on. We'll take some measurements. You'll see how fast the motor starts with this one capacitor. So, started right up. Let's take some voltage measurements. Again, doing the overall. 238 unchanged. We'll do the VAC. 206, so that dropped a little bit. It was 210, 211. And now we'll do the VBC. And that is 258, which is a little high. Well, let's keep going. I'm going to add the capacitors I bought and see what happens. Maybe I'll have to get different capacitors. Again, I got to shut the power off. Bear with me. Branch video, you see he added a larger capacitor to start, but he also had a larger horsepower three-phase motor. I have a smaller one, so what I'm going to have to do is I will add the other one that I bought, which is the same as this one. It's an 80 dual run, and then we'll take some voltage measurements and we'll see. Maybe I'll have to get some more capacitors, but let's see. Overall voltage remains the same, 238, 240. VAC 255. VBC 290. So those voltages are too high, so I'm going to have to change the capacitors to something smaller. So I'll probably have to order those capacitors. Let's see, I want to be at least 30 microfarads down from where I'm at. So I'll order something about a 50 or so instead of these 80s, and I'll see what we got. Alright, it's been a few days, and I got some of the smaller capacitors that I was going to order. They finally came in. Not in the best of shape, some dents, but as long as they work, I don't really care. So again, we're going to hook these to C for common. I'll hook it up on the one side first. And then we'll take a measurement. We'll do the motions. Okay. Again, listen to the starting of the motor. And let's take some measurements. Overall voltage, 238, 240. We'll measure the leg that had the 212 roughly. 205, so it did come down just as the document says it will. And this was the one that was 200 or so. And we are at 241, so we're roughly exactly where that one needs to be. The only thing that's probably going to happen is when I add this other capacitor to the other side, it's going to kick this up, and that one will probably be right where it needs to be. We'll see. Let's add it. $239. VAC, this is where we originally started at about 210. We are at 248. This was the ghost leg over here. This was originally 200. $267. So you see, that one pulled that one up. This needs to be a little bit lower because of my motor, even though at the beginning of the video I said that it was a new motor, which it is to me. It looks like a new motor in great shape, maybe rebuilt, something wrong with the insides, but this one could stand probably dropping another 10. I think I'm going to let this thing run the way it is for a little bit, get some readings on it, maybe start the lathe up, see what happens with there, see how it is. So now let me check, since we're here, before I turn it off, and add the one that balances the A and the B. Let's go to amps. We want to see if the motor amps are roughly balanced. So this is the L1. We're at 3.8, 3.7. This is a 5. This is the L2. And ghost leg is a little bit higher, which is the way it is higher, even in his document. But they're not really far out of whack. It's not like I've got one that is 15 or 20 or something. So they're all within range of this motor. They're all within range of this circuit. This is all on a 30 amp circuit, 240 volt. So let me add the final capacitor, which will be from here, here, which will balance out these amperages. So again, we were at 3.5, 5, and 8. Let's double check. And 4.9 this time, 5.5, and 9. So we are a little bit higher than when we were the first reading. But let's see what happens. I got to turn the power off. Let's see. With that added capacitor, final one. But switch back to our goes. $239 AC, 247, VBC 272. So everything went up quite a bit. Let's see how the amps go. I might really need to drop this one down here. Back to amps. See, back to what it was before. 3.7, 3.5, 6.2, 9.6. Okay. Other than maybe dropping this capacitor down, I'm happy with the way this is going so far. Again, I started with a static phase converter that I was not happy with the performance on the tools with it. And if I can build up using this method, then it saves me that engineering portion of it. And I can get through this a little bit quicker. But let's see if the lathe will start up. Alright, let's take some readings while the lathe is running. $239, $225. $251. So that's not horrible with a load. Let's see what amps it's pulling while it's running. This is a 1,000 RPM roughly. 4, 8, 9. So even the amps are fairly balanced. I know they're not spot on, not right on the money, but they're really close. So I'll have to weigh a little bit and see if I want to pop that down to a 40. But I'm pretty happy the way everything is running at the moment. It proves out the concept that it works. That engineering does what it's supposed to do. This engineering does what it's supposed to do with some tweaking. Alright, I don't know if I'll probably put this out as a video, and maybe your comments, I can go further as far as the testing goes, or I can leave it run and give feedback on how it's running. But I'd like to get this done so I can take my 240 power that I have right here, hook up my 3-phase rotary converter to it, which is going to end up in this spot here, and backfeed it around over to where my surface grinder's at. Because I want to keep the 240 here to hook the compressor back up. So, alright, let me know what your thoughts are, and we'll go from here. If you would like to see how I put the box together, let me know that too. But otherwise, I'm going to put this out the way it is. This was the thing that I was most interested in. Not necessarily putting this in an enclosure the way SBIRDRANCH did. His video is adequate enough for showing you guys options there. He's going to go through more of the safety options than I will. I'm not going to do that. I'm not in a big place. This is just a 2-car garage. I'm by myself. Thanks a lot. Oh, and remember, please like, subscribe, share, suggest, tell all your friends about this. I appreciate the subscribers I have. I appreciate the emails. I appreciate everybody that's joining me on my channel. I enjoy doing these kind of projects, but it'd be nice to have a bigger fan base. So, you know, if you like it and you know people that might like this type of content, suggest +8 Precision to them. Thanks a lot.